So we will start with example 13, okay, that involve some knowledge that we learned in the previous video also. Okay, so generally they give you a Cartesian form complex number here. For u, it is equals to 2 plus I, and then the conjugate is u star, which is something that we learned before lah. Right, so for part number 2, they want you to express u divided by u star in the form of x plus yi. Okay, so this is something very basic, so I think I will not show you the details out of the step. I will just guide you how to do it, then you try to get the final answer. So they said that they want you to find out u divided by u star. So u divided by u star means that you should have 2 plus I divided by 2 minus I. Okay, because the conjugate of u should be 2 minus I, like the sign of the imaginary part is different. Okay, then because of we are not going to keep our answer, okay, with the complex number at the denominator part, therefore you need to rationalize it. So how are you going to rationalize it? So you need to multiply the 2 plus I and also 2 plus I for top and bottom. Okay, so if you continue to expand and try to rephrase everything, the final answer for u over u star that you get should be 3 over 5 plus 4 over 5i. Okay, so please complete the step here, the steps missing here. All right, it is quite basic, something very basic that we learned before. So I just hope that you can take this chance to see whether you still remember or not. All right, so the answer for u over u star should be 3 over 5 plus 4 over 5i. Okay, so part 2 is very simple. Then now we continue to part number 3. Okay, so for part number 3, they want you to consider the argument of u over u star, or otherwise, they want you to prove this result. Okay, so here they give you a hint. You should always consider the argument of u over u star first. Okay, so you need to start from the argument to prove that the left-hand side equals to right-hand side. So how are we going to prove this? Okay, so first of all, since you know that u over u star from part number 2, you get a complex number which is 3 over 5 plus 4 over 5i, right? Okay, so what is this argument u over u star? Okay, so according to the basic knowledge that we learned before, the argument of u over u star, you need to look at the Cartesian form equation. So this one is the first quadrant. This is in the first quadrant. Therefore, to get the argument u over u star, you will have tangent inverse b over a. So b is 4 over 5 divided by a, which is 3 over 5. Okay, and when you try to simplify it, you will have tangent inverse 4 over 3. All right, and you can see that this answer is actually your left-hand side of the equation. So this is the left-hand side answer. Okay, and then how can I get the right-hand side answer? All right, so again, by considering also the argument of u divided by u star. Okay, so according to the latest formula that we learned, argument u over u star, you can also write it out as argument u minus argument u star. Right, this is the latest formula that we learned, that you can use it to calculate the argument for u over u star. So you can separate, become argument u minus argument u star. So what is argument u? All right, so if you have a look here, since u is 2 plus I, and then u star is 2 minus I. So if you look at the detail here, this one is in the first quadrant, and this is in the fourth quadrant. All right, so to find out the argument u, the formula will be quite simple, which is tangent inverse 1 over 2, okay, minus the argument u star. So since the argument u star is in the fourth quadrant, right? So if you refer back to the very basic formula that according to quadrant 1, okay, what is the argument for the fourth quadrant? So it will be negative tangent inverse b over a for those complex number that's in the fourth quadrant. Alright, so you will see that it will become tangent inverse 1 over 2 plus tangent inverse 1 over 2 as well. Therefore, you will have 2 tangent inverse 1 over 2. So this is the expression on the right hand side. Okay, so since you can see that both these answers, right, they are referring to the argument of u over u star. So the argument for u over u star should be the same for the left and right hand side. So you can just write a conclusion saying that the tangent inverse 4 over 3 is equals to 2 times of tangent inverse 1 over 2. Because both of them are the argument of u over u star. Just that when I try to find out the argument u over u star, I'm using two different methods. The first one is you try to find out u over u star in the Cartesian form first, then you should apply the formula for the argument. Another one is using the formula of the concept where we are having argument u over u star is equals to argument u minus argument u star. Okay, so let us continue to example 14. There's a complex number z, so they give you complex number z as something like this. Okay, so by show your all your working lah. So first they want you to express z, okay, in the form of r e power I theta, where r greater than 0 and also the theta is between negative pi until pi. Okay, so first of all you need to know what is the r here lah. So I think I told you before, r is actually the modulus of z, and the theta is actually the argument of z. Okay, so for this question, there are two methods for you to solve it. I will show you both. Okay, the first method that I show you here is the easier method. And the second method, I will not show you fully the steps, but I will guide you how to do it. So you can compare and see which method you prefer. All right, you prefer more, then you can apply in the exam. But actually, both are correct. Okay, if you want to apply in the exam, you can choose one of them that you feel that is easier for you to understand or easier for you to apply. Okay, so since I know that I need the modulus and also the argument, right? And if I look at the z, the complex number z, you have two parts, right? It is a fraction. So on top is one of the complex number, at the bottom is another complex number. So maybe what I can do here is maybe I will try to write out, assume that this is w, the complex number w, and then I assume that this one is the complex number s, let's say w and s. Okay, all right, so now if I want to find out the expression of z, okay, and before that I need to get the modulus z. Okay, so if I want to get the modulus z, since I assume that z is equals to w over s, right? So which means if you want to find the modulus z, you can write as you find out the modulus of w. This is the modulus of w lah. Okay, then divided by the modulus z. So, sorry, the modulus s. So the modulus s will be square root 3 minus I. Okay, so how to find out the modulus of w? So it will be a square plus b square square root. So a square plus b square square root. This is the modulus for w on top, divided by the modulus of s at the bottom. So what do you have here is square root 3 square plus negative 1 square. Okay, so if you try to get all the modulus, it will be square root 324 divided by the square root 4. And you will get 9 as the modulus of z. So this is your r. Okay, so generally you can see that this formula is the latest formula that we learned in the previous video or previous two videos. Alright, where if you want to get the modulus of z, you can actually separate them, become modulus of z divided modulus of w divided by the modulus of s. Okay, then the same thing happened here. If I want to get the argument of z, so it is actually equals to what? Argument of w. So w is 9 square root 3 plus 9i, this is w, okay, minus the argument of s. So the s is square root 3 minus 1. So argument w minus the argument of s, because of they are divided, right? W divided by s. So for argument, you minus. Okay, so again, to get this argument, it is in the first quadrant. So for this argument, it is in the fourth quadrant. All right, so you need to apply some basic knowledge on finding out the argument. So to find out this argument, it should be tangent inverse 9 divided by 9 square root 3. Okay, then minus, for this one, it is in the fourth quadrant. So for fourth quadrant, the formula is negative tangent inverse. Ignore the negative here. Then you have 1 over square root 3. Okay, so from here you can try to press calculator and see what they give you. What is the answer that they give you? So you should have 30 degree, which is pi over 6. Then for this part, negative and negative become positive. So this value itself is also pi over 6. All right, so end up you're having pi over 3 as the answer. So this is the modulus, this is the argument for z, and this is the modulus of z. And since they want you to write out z in this pattern, therefore, you can write out again the answer that they want. So z is actually equals to 9 e power pi over 3i. So this is your correct answer for the pattern that they want. Okay, so this is the easier method that I think uh, is easier lah. To me, it is easier compared to the second method that I will show you later. All right, but you need to know how to apply it. No? Okay, in this question, it didn't give you any hint, right? So you need to try to link. Oh, okay, I can make it as this fraction as two different complex number, which is become w divided by s. Then you apply the formula that you learned just now in the previous video to get the modulus and also the argument. Okay, all right. So this is what we have. So now, if let's say you want to use the other method where I feel that it is harder, then how will it be? Okay, so I will just guide you lah, okay, how to do that, and then maybe you can try out on your own. Because to me, I think it is slightly longer, the steps, and also a bit more complicated. Okay, then it depends on you lah. You decide yourself, okay, which one you prefer more. Okay, so now, since just now they give us the complex number z, right, which is 9 square root 3 plus 9i divided by square root 3 minus I. And since I know that to get the modulus and argument of the z, right, so I need to have the z in x plus yi form first, which means I need to rationalize it. So to rationalize the z, you need to multiply it with square root 3 plus I and also square root 3 plus I on top. Okay, so again, you can try to simplify everything here, expand and then simplify. Your final answer for z should be 9 over 2 plus 9 over 2 square root 3i. So you get a z here. So you get this z first. Okay, so after you get the z, you want to get the modulus, right? So from here, you should apply the formula. So if you apply z equals to 9 over 2 square root 3 square plus 9 over 2 square. Okay, so if you continue again, you also get the same answer, which is the 9. All right, then for the argument z, also you apply the formula. So this is in the first quadrant. Okay, so this is in the first quadrant. So what you need to do is you straight away apply the formula tangent inverse 9 over 2 square root 3. Okay, so 9 square root 3 over 2 divided by 9 over 2. So end up you realize that you will also get the answer, which is pi over 3. The answer is the same actually. Okay, so just that you can see that to find the modulus z and also the argument z, you need to get the z first. Okay, maybe to some of you, you will find that this method seems like easier to understand, right? You just need to rationalize it. Okay, you just need to rationalize it, and then after that, you can find out the modulus and argument for the z. Okay, straight away. All right, but in my opinion, right, the process here is a bit complicated because you might do careless mistake very easily since you are having all the cert form. I don't know lah, it depends on how you feel. Okay, so some students will tell me they prefer this way. All right, so some students they say, okay lah, seems like this way is easier. So it depends on you which method you prefer more. All right, so just to let you know that if you want to use the second method, the very first thing is you need to make sure you find out the z first in the Cartesian form. Okay, so if you get the z in the Cartesian form already, then you can straight away get the answer. Right? Okay, so there are two methods here to show you, okay, to let you choose on your own which one you prefer more. All right, okay, then now let's continue to part number 2. So for part number 2, they say that they want you to find out the square roots of z. Hope that you can see it, okay? So they want you to find out the square roots of z, giving your answer in this form also. Okay, where r greater than 0 and also theta is between negative until positive pi. Okay, so again, I will roughly tell you the answer. Okay, I will roughly tell you the steps. Okay, so let us continue with part number 2. Part number 2. Okay, maybe for part number 2, I do it like this. All right, so for part number 2, because now they are asking for the modulus and argument. Oh no, they are asking for the square root. Okay, the square root of z. Okay, so to get the square root of z, square root z. Okay, so you can find out the square root of z straight away by using the formula that we learned before in the third case just now. You can refer back to the previous video for the third case. When you want to get the modulus of the square root z, it is actually equals to the square root of modulus z. Okay, so now I apply this method is because of I already get all the information that I want from part number 1. So you can see that the z modulus is 9, right? So the square root of 9, you get a 3. So that means the modulus of the square root of the complex number z is 3. Okay, then after that I want to get the argument of the square root z. Okay, so to get the argument of square root z, you have two answers. The first one is half of the argument. Another one is half of the argument plus and minus pi. Okay, so either plus or minus, right? We need to decide it later. Okay, so what I want to do now is I want to put in my theta. So the theta means argument of z. So this is the argument of z. Can see that? So you are having half, then pi over 3. Okay, then for this one is also half pi over 3. Okay, now I want to decide whether is it positive or negative. So if you look at half pi over 3, you're having pi over 6. Okay, so for pi over 6, right? If you plus pi, that means pi over 6 plus pi. This answer is 7 pi over 6. Okay, so 7 pi over 6 is out of range already. Why is it out of range? Because our data, right, our argument for syllabus, the definition is between pi until negative pi only. So 7 pi over 6 is already more than pi, which is out of the range. Therefore, for the adjustment here, or for the second answer here, it shouldn't be plus pi. It should be minus pi. Okay? Alright, so it should be minus pi. So this is something, some small analysis, you need to do it on your own. Alright, in exam or maybe in the notes, they won't tell you so detailed. So you need to decide on your own. Okay, so when you try to simplify, you will have pi over 6. Another answer is pi over 6 minus pi. And therefore, you will get negative 5 pi over 6. Okay, therefore, for the square root of modulus z, the square root of z, the answer, you have two answers. The first one is 3e pi over 6I. Another answer is negative, another answer is also 3e then negative 5 pi over 6I. So these are the two answers for the square root of z. Okay, so this is the first method that you can do. So in my opinion, again, if I apply this formula from first part until this part, generally for this part, your step is quite short because you straight away apply the formula only for the square root, modulus, and also for the theta, you divided it by half. Then you get the second answer by either plus pi or minus pi lah. Okay, so you can double check if you get negative 5 pi over 6, it is still within the range, which is from negative pi to positive pi. Okay, and when you write out the final answer in the exponential form, this is what requested by the question, right? So this is the two answer for the square root of z. So I think this is quite short. Okay, then now, if just now you apply the the second method that I showed you just now. Okay, second method. So now I use the second method to show you how to do it also, but I will not show you the full steps because this is quite long. Okay, so since you already get the z just now, which is 9 over 2 plus 9 over 2 square root 3i, right? Okay, so for second part, if you want to get the square root of z, then how should you do it? So you let the square root of 9 over 2 plus 9 over 2 square root 3i equals to a plus bi. So this method we learned it quite early, right at the beginning of the chapter. So what's the next step? So you are let 9 over 2 plus 9 over 2 square root 3i equals to a plus bi. Then you expand your equation. Then you compare the real part with real part. So after expansion, you should have a square minus b square plus 2abi. Okay, so again, you can compare. You will form two equations here. Okay, by comparing the real part. This is the real part. Compare with the real part. And then for imaginary, you compare it with imaginary. So this is imaginary, right? So you compare it with imaginary. So from these two equations, you solve simultaneously. All right, so what do you have here? You will have a square minus b square equals to 9 over 2. Then 2ab equals to 9 over 2 square root 3. So this is the first equation. This is the second equation. You solve the equation simultaneously, then you get the answer, two set of answer for a and b. After you get the a and b, then only you try to find out the modulus and argument for a and b separately, the two answers separately. So it is quite long actually. Okay, so but of course the final answer that you get for the modulus is still the 3, the argument. One of them is square pi over 6, another one is negative 5 pi over 6. Okay, so to me, right, I will not continue because in my opinion, this is very, very long, the methods, the steps. All right, so after you solve it, you get two answers. That means you get root 1 equals to one value. Then you get root 2 equals to another value, right? Another complex number. So for root 1, you need to find out the modulus and also the argument. Then for root number 2, you also need to find out the modulus and also the argument, which I feel that it is quite long the step. Okay, so you can see that if comparatively, for the first method here that I'm using and also this second method, okay, for square root part, this one definitely much more shorter. All right, so that's why I think that the formula that we learned in the previous two videos, right, somehow it is quite useful for some certain questions. So this is one of the example. Okay, because if you use the basic method, still can get the answer. Okay, this is the basic method that we learned since early. Okay, since the beginning of the chapter. So you can see that you can still get the answer, just that maybe it will be slightly longer. All right, so it depends on you. In exam, if let's say you found that, okay, you know how to apply this, you can apply. But if you found that it's quite hard for you to understand and interpret this one, right, then you can still stick to the basic method. Just that you need to be extra careful, okay, because this method is it is longer. That's the first thing. And the second thing is this question got all the cert form. So when you want to simplify your answer, please make sure that you double check, okay, for your final answer. All right, so this is some of the example that I can show you how we use the formula that we learned just now or in the previous video, okay, to apply it in the exam style question. Okay, so here we ended the very first part of complex number already, all the calculation, okay, and also all the solving part lah, for all the roots and everything. So in the next video, we are going to discuss the second part where we need to learn how to sketch all the locus, okay, of a complex number. Then we are going to use all the locus, all the graph to answer the question. All right, so we'll discuss that in the next video.